Question 2 is an electricity question, and what you're looking at here is a current voltage graph or current potential difference graph, and you need to know these for a whole bunch of components, including a normal resistor and a light bulb. This one in particular is a diode. Diode is unusual because it allows current to flow in one direction but doesn't allow it to flow in the other direction. So you just need to learn these. And you're allowed LED there, which is a light emitting diode. They don't care whether you put that or not, as long as you've got the word diode in there. Now, the next part is asking for a measurement. So complete the diagram to show a circuit that can be used to obtain the data needed to plot the graph. So we need to be able to plot current and voltage. Now we've already got an ammeter in there. So that means we've got the current part covered. We don't need to worry about that. The only thing we need to put in is the diode itself and a voltmeter, so we can measure the potential difference or the voltage. So this is what the circuit should look like when you're finished. Okay, the diode needs to go in the circuit, and then added in parallel to it is a voltmeter. Voltmeters are always added in parallel to the component they're trying to measure the voltage of, and ammeters are always in series, so they're in the same loop in the circuit. Okay, this over here is a variable resistor. All that allows you to do is to change the total resistance of the circuit, so you can actually change the current through it and the voltage across the diode. So that allows you to get the different points on the graph. The voltmeter allows you to measure the voltage, ammeter measure the current. Now if we look at what you should have done from the mark scheme, you've got 1 mark just for putting the diode and the voltmeter in anywhere. Another important thing to realise is if you didn't know it was a diode in part A, and you put, say, a light bulb down, then if you'd put a light bulb in the circuit in such a way as you could have measured the voltage across the light bulb, then you would have got a mark for that as well. Okay, it says allow ECF. Whenever you see ECF in a mark scheme, it means error carried forward. That means if you've made a mistake up here, you don't get punished for it again down here. You lose the mark once and that's it. Okay, ignore polarity of the diode means they don't care which way round it goes. I've actually got mine in backwards as well. Doesn't matter, right? Should really be pointing the other way. They didn't care about that. And the other mark was for having the voltmeter in parallel. Okay, if you put it in series, you only get 1 mark. Okay, 2C part 1. What is the current through the component when the potential difference across the component is 0.8 volts? Well, for that we need to go back to our graph and look on our potential difference axis. And we need to find 0.8. Now, one thing that goes wrong a lot when reading off graphs is kind of assuming what the scale is without really checking. So if we look at this in a little bit more detail and zoom in to the graph, then what you can see is that there are 10 squares between 0.5 and 1.0. So that means that each 2 squares is going to be 0.1. So here is 0.6, 0.7, and 0.8 is here. Big mistake that people make is to go, oh, well, there's 0.5, 0.6, 0.7, 0.8, and say there, and you get way too low a value. So 0.8 is here, and if we read up, we go up until we get to the line, and across we can see that the current in amps is 0.05. Try not to make mistakes when you're reading off here as well. 0.5, common mistake. Okay, make sure you read off your graph really carefully. Okay. So there you go, there's the 0.05. And there's a margin for error in these, right? It says you're allowed slightly below as well. If you look, it kind of looks like the line might be just a tiny bit below 0.05. Okay. So, 2C part 2. Use the equation in the box to calculate the resistance of the component when the potential difference across it is 0.8 volts. Now, what you've got here is you're after the resistance, and the resistance is not at the start of the equation. It's not what we call the subject of the equation. Right, so we have to rearrange this equation. We want resistance on its own. We need to get rid of the current here, so we need to divide by current. And that means that resistance is going to be potential difference divided by current. Now there's a triangle method for this, and there's a separate video to look at how the triangle method works. So if you're not sure how to rearrange equations, go and look at that video. Go and look at that triangle method video, and it will show you how to do it. But if we look at the mark scheme here, we're taking our 0.8 volts, which is given to us in the question, and we're dividing it by the answer we found in this first part here. Now again, you get marks. No matter what you've put up here, if you correctly put it into here, you get a mark. Okay? So 1 mark for correct transformation and substitution. What that means is you get 1 mark for sticking this number in and rearranging the equation. Okay? You get both marks if you get it absolutely right, which is 16 ohms. Okay, and that's it.